It's Adam here with John Dalton's first postulate. The first postulate is that all atoms are indivisible and indestructible. What this means is that Dalton came up with the law of conservation of mass, and it could be explained using the idea of the atom. He hypothesized that all matter is made of tiny, indivisible, indestructible particles called atoms, which he imagined as solid, massy, impenetrable particles. Dalton did not have the necessary instruments to experiment on these particles, so he had no way of knowing otherwise. They could have any internal structure or any external structure. We might visualize Dalton's atom as a piece in a cardboard modeling kit, where different elements are spheres of different sizes and shapes. While this is a handy model for some applications, we now know that the atoms are far from being solid spheres.
What's up, John Dalton's postulate nation? It's Evan here with the second postulate.
John Dalton's second postulate is all atoms of a given element are identical both in mass and chemical property. Dalton proposed that every atom of an element, such as gold, is the same as every other atom of that element. He also noted that the atoms of one element are from the atoms of all other elements today. We still know this to be partly true. A sodium atom is made from a carbon atom. Elements may share similar boiling points, melting points, and electronegativities, but no two elements have the same exact set of properties.
Hey guys, John Dalton here with third postulate. Atoms are formed by combinations, or are made from different kinds of atoms. John Dalton's third postulate is part of the atomic theory. He proposed that combinations are made of two or more different types of atoms. An example of such compound is table salt. Table salt is a combination of two separate elements with unique physical and chemical properties. The first, sodium, is a highly reactive metal. The second, chlorine, is a toxic gas. When they react, the atoms combine in a 1-to-1 ratio to form white crystals of NaCl, which we sprinkle on our food. Since atoms are indivisible, they will always combine in simple whole number ratios. Therefore, it will not make sense to write a formula such as Na underscore 0.5 to start subscript 0.5n. You can't have half of an atom.
John Dalton's fourth and final postulate.
That is, chemical reactions is a rearrangement of atoms. In the fourth and final part of Dalton's atomic theory, he suggested that chemical reactions don't destroy or create atoms, they merely rearrange atoms. Using our salt example again, when sodium combines with chlorine to make salt, both sodium and chlorine atoms still exist. They typically rearrange to form a new compound.
This is the law of multiple proportions. John Dalton's law of multiple proportions was first observed in 1803. The law states that when elements combine, they do so in ratios of small whole numbers. For example, carbon and oxygen react to form CO or CO2, but not CO1,3. For instance, furthermore, it states that if two elements form more than one compound between them, then the ratio of masses of the second element combined with the fixed mass of the first element will also be in ratios of small whole numbers. John Dalton first expressed this observation and is sometimes called Dalton's law, although this term usually refers to his law of partial pressures. Another example, two different compounds are formed by elements carbon and oxygen. The first compound contains 42% biomass carbon and 57% biomass oxygen. The second compound contains 27.3% biomass carbon and 72.7% biomass oxygen. Show that the data is consistent with the law of multiple proportions.
For John Dalton's atom, it has, of course, two rings, each having electrons on it, which are these things. There was three at one point. Then it goes to a middle where it has two protons and two neutrons. They would have been the same size if we actually had time. The pipe cleaners are just there to hold this unstable frame together. This model is actually pretty accurate to what scientists now think the atom looks like. Well, so it has more. They believe there's more rings and electrons now. But that basically explains it.
It starts with
one thing, I don't know why. It doesn't even matter how hard you try. Keep that in mind. I designed this
rhyme to explain in due time. All I know, time is a valuable thing. Watch it fly by as the pendulum swings. Watch it count down to the end of the day. The clock takes life away.